All right, so finishing up this homework number 24, we're on question number 45, and it says find the intervals of convergence of f of x, f prime, f double prime, and the integral of f of x. So remember, f prime, f double prime, the integral of f, all of the calculus-based power series will have the same interval or radius of convergence, I should say, except that the endpoints might be included or excluded depending. So it's only the endpoints that change. So once I find the interval of convergence for part A, I will use those same numbers for B, C, and D. I'm really just checking the endpoints once I get those power series. Okay, so for part A, this is a geometric series. So for part A, I can say that this series converges by the geometric series test if the absolute value of x over 3 stays less than 1. And that means that -1 is less than x over 3, which is less than 1. And that means that x is anything between -3 and +3. And that will be our interval of convergence. If you have a true geometric series like this, meaning there are no other values for x or values for n outside of this radius to the nth power, then you don't have to check the endpoints. Okay, for part B, we're supposed to find an f prime of x power series and then find its interval of convergence. So remember, you can just do derivatives within the power series. So I'm just going to use power rule on this and say, so this would be the series from 0 to infinity of n times x minus 3 to the n minus 1. Now be careful here. You have to remember to chain rule too. You just took the derivative of x over 3 to the n power. So there will also be a times 1/3 in the end here. And you can simplify that if you'd like to. I'm going to because I do need to check the endpoints. So instead of having an n times 1/3, I'm just going to have an n over 3 right here. And then it's x over 3 to the n minus 1. So again, the interval of convergence I know is between -3 and 3, but I need to check and see if I'm including either of those endpoints. So let's check to see if x is -3, what would that make this series? So this becomes n equals 0 to infinity. You would still have an n minus 3 out here, or I'm sorry, an n divided by 3 out here. And then -3 divided by 3 would be -1 to the n minus 1. Now, this is an alternating series, but the terms are not decreasing towards 0. So this series would diverge by the nth term test because the limit as n approaches infinity of n over 3 equals infinity. So diverges by nth term test. And let's check to see what happens if x equals 3. So remember, for a free response question, you need to show what series you would get when you do that. So you would have n over 3, and then this would just be times 1 to the n minus 1, so you don't really need to include that. So again, this would also diverge by the nth term test. So that means that this interval of convergence is the same as it was in part A. We are not including either of the endpoints. Part C says find f double prime of x. So now this just means taking the derivative of the derivative. So I'm going to use my simplified version here. So you would have n over 3, that's a constant, multiplied by the new exponent, multiplied by the old exponent, over x over times x over 3 to the n minus 2. And then again, you'd have the chain rule in here, times 1/3. So let's just clean that up so that we can check the endpoints again. Now, I should probably be adjusting the n value. Like if I write out terms for these, this doesn't really matter for my interval of convergence, so I'm not worried about it. But if they were just asking me for the power series, I would double check. I don't want any of my terms to give me x to the negative anything. So like if I plug in 0 here, that's not going to work. This one would probably start at n equals 1, and this one would start at n equals 2. So something to think about there. I'm going to have an n times n minus 1 over 9 times x over 3 to the n minus 2. And it's really just the interval of convergence that we care about. So if x equals -3, this I think is going to give me the same scenario I had on the last problem. So we'll have n times n minus 1 over 9, and then -3 divided by 3 will be -1 to the n minus 2. So it is alternating, but again, this is a top-heavy expression, so this will diverge by nth term test. And if x equals 3, again, I'm getting those values just from the original interval of convergence from f of x, because performing calculus does not change the radius of convergence. If I plug in 3, I would get 1 to the n minus 2, so I don't really need to write that. It's not included, and so I can say diverges by nth term test. So again, this one is still -3 to 3. All right, and then part D wants us to take the integral of f of x dx. So go back to your f series and integrate that. So again, I could think about if I were expanding terms out, if I needed to know what this n really was, if it's going to be 0 or 1 or 2 or whatever, I could expand terms out for f of x and expand terms out for what expression I get and just see what n would have to match up with that to get those terms. I'm not going to worry about that right now. So x over 3 goes to the n plus 1, gets divided by n plus 1. And again, you would have had u sub here. So if u is equal to x over 3, du dx is equal to 1/3. So 3 du is equal to dx. So there needs to be a 3 out here. All right, now we check the n's again. So what if x equals -3? Then we get the sum from 0 to infinity of 3 times -1 to the n plus 1 over n plus 1. Now this is an alternating series. It's bottom heavy, so its terms are approaching 0. So this series converges by the alternating series test. And then let's check and see what we get. If we plug in x equals 3, we get 3 times 1 to the n plus 1, so unnecessary, over n plus 1. Now this is not alternating. This is one of those general harmonic series, so this diverges. I know it diverges because it's a general harmonic. If you think back to which test we always had to do to make that happen, it was LCT with the harmonic series. Or integral test before we knew about LCT and DCT. So we are including -3. We are not including 3. So -3 is less than or equal to x, which is just less than 3. Or you could use interval notation for either of these, where you use a square bracket on -3 and parentheses on 3. Okay, let's take a look at 46. A bit more complicated. Same instructions. First, find the interval of convergence for f of x. So this one needs the ratio test because it's got lots of stuff happening. So limit as n approaches infinity of the absolute value. So this will be x minus 5 over n plus 1 over n plus 1 times 5 to the n plus 1. Multiply that by the nth term, the reciprocal of the nth term, I should say. And what will we have left? So there's lots of stuff to cancel. This n will stay here. I'll have an x minus 5 to the first because those n's cancel. I will have a 5 to the first in the denominator and an n plus 1. So this limit comes out to the absolute value of x minus 5 over 5 because n over n plus 1 approaches 1. And so this series converges by the ratio test if the absolute value of x minus 5 over 5 remains less than 1, which means x minus 5 over 5 is between negative 1 and 1. So let's solve this for x. Radius of convergence is 5. Add 5 to both sides. Check the endpoints because we did a ratio test. So this alternating, anytime the series is alternating, it might have the chance to converge at some of those endpoints. So let's look at if x is 0. Oh, and this one tells us to go from 1 to infinity. So if x is 0, going back here, I've got negative 1 to the m plus 1. You'll have negative 5 to the n over n times 5 to the n. Now take a look at these 5s right here. These are both to the n, so you're allowed to make that negative 5 divided by 5 to the n, or basically that's negative 1 to the n plus 1 times another negative 1 to the n over n. So is this alternating or not? Add your exponents on your negative 1. You get negative 1 to the 2n plus 1. If you're not sure, plug numbers into this, but 2n will always force a number to be even. Adding 1 will always make it odd. And negative 1 to an always odd power will always be negative 1. So this series might as well just be negative 1 over n. And that diverges because it's a harmonic series. All right. Or you could say p-series test. And then what about with 10? If x equals 10. So you've got negative 1 to the n plus 1 is built in. 10 minus 5 will leave us with 5 to the n over n times another 5 to the n. These 5 to the n's can cancel out. They divide out to 1. And this is an alternating series. So this side converges by alternating series test. So we are leaving out the 0, but we are including the 10. Now, we should have the same radius and same interval for the other parts. We're just checking the endpoints now. So for part B, f prime of x. All right, so f prime. I would have, again, the starting value might need to change a little bit, but I'm not really worried about that for interval of convergence. So this is going to become n times x minus 5 to the n minus 1 over n times 5 to the n. There's no chain rule to worry about here because the derivative of x minus 5 is 1. Okay, and then I can simplify things. So the n's cancel. Let's see. Now I have that I did simplify this a bit. Maybe I just want to leave this. Never mind. I'll just leave. Actually, no, I want to make it match my key. So, okay, I could keep going from here and test my endpoints, but I want to talk about what I was doing in the previous one. I did pull this out and say, let's look at this series. I think I did this thinking it might be easier to take a derivative, but I don't know. I'll just explain this, but I'll keep going with what I've done here. So I made this x minus 5 over 5. That's all to the n, and there's still an over n down here. So then when I took my derivative, I did n times x minus 5 over 5 to the n. And then I also had a minus. I had a chain rule. I had a times 1/5 out here as well. Let's just keep going with this. What if we just do this? So let's test this into what if x equals 0? What would that make our series? So we'd have a negative 1 to the n plus 1. 0 makes this negative 5 to the n minus 1. So let's do this. Negative 5 to the n times negative 5 to the negative 1 over 5 to the n. Why do I want to do that? Because I want to see what where the negative 1 is. Like this is negative 1 to the n. So this is actually the integral from 1 to infinity of negative 1 to the 2n plus 1. And then negative 5 to the negative 1 just puts a negative 5 down here. And that would give me, let's see, a non-alternating series. This is the same as saying, oh, you've just got the integral from 1 to infinity of negative 1 over negative 5, or 1/5, and that diverges by the nth term test. The terms are not approaching 0. You're just adding 1/5 every time. What if x equals 10? So negative 1 to the n plus 1. This gives you 5 to the n minus 1. So how about 5 to the n times 5 to the negative 1 over 5 to the n, just to get things to cancel nicely. All right, so this is an alternating series, but just because it's alternating doesn't mean it diverges. You're alternating between 1/5 and negative 1/5, back and forth. So this diverges by nth term test because the terms are still not approaching 0, even if they're alternating. So for this one, we don't include either endpoint. X is just between 0 and 10. For part C, I kind of want to do part C right here so that I can see the derivative more easily. All right, so let's see. What would this become? F double prime of x. So you've got a negative 1 to the n plus 1. Remember, these n's canceled. So we would now have an n minus 1 that gets pulled down times x minus 5 to the n minus 2 over 5 to the n is just a constant. Again, I might have had something slightly different on my key because I had the x minus 5 over 5 lumped together. But in the end, we get to the same place. So let's just check the endpoints here. So if x equals 0, I get the sum from 1 to infinity of negative 1 to the n plus 1 times n minus 1. And then this becomes negative 5 to the n times negative 5 to the negative 2 over 5 to the n. That's going to be negative 1 to the n. And I think we're in a similar situation here. We've got a negative 1 to the 2n plus 1. That's always odd. Times n minus 1. I can send this negative 5 squared down to make it just 25 down here. But again, these terms are not decreasing towards 0, so this diverges by the nth term test. All right, and then let's see. What if x is 10? So we have negative 1 to the n plus 1 times n minus 1. And this would become 5 to the n times 5 to the negative 2 over 5 to the n. So the 5 to the n's cancel. Same thing is happening, though. This will diverge by nth term test. Because you'll get n minus 1 over 25 in alternating, and it's still just not going to pass that test. So this one is 0 to 10. And then we need to do the integral. So part D, the integral of f of x dx. So let me remind myself what this was here. All right, so we would have the sum from 1 to infinity. So there'd be a negative 1 to the n plus 1. X minus 5 will now be to the n plus 1. It will need to get divided by its new exponent. And you already had down there n times 5 to the n. So if I keep it separate like that, I don't have to think about u sub. In my version where I merged these together, I would have to have, it would be negative 1 to the n plus 1 times x minus 5 over 5 to the n plus 1 over n times n plus 1. And I'd have to have a times 5 somewhere because u sub here. All right, so I don't have to think about all that. There's nothing really to cancel, so let's just check our endpoints. So if I plug in 0, I get -1 to the n plus 1, -5 to the n plus 1, so let's do what we've been doing, over n times n plus 1 times 5 to the n. So here's -1 to the n. And I think this is going to actually converge because it looks bottom heavy. You've got -1 to the 2n plus 1, which is always odd, over n times n plus 1. Oh, and the -5 to the, oh, and there's a 5 up there. Sorry, there's a -5 up here. So this is -5 over n squared plus n, right? And it's actually +5. Sorry, let me clean this up. This is always -1 times -5, so 5 over n squared plus n. This would converge by dct with 5 over n squared. All right, and then what if x is 10? You've got -1 to the n plus 1. If I put 10 in here, I get 5 to the n times 5 to the first over n times n plus 1 times 5 to the n. So those cancel. This will converge because it is alternating and terms are decreasing towards 0, so alternating by alternating series test. So this converges at both parts, both ends, I should say. All right, now our last couple here, I kept my answers for. 58 just says describe the radius of convergence and the interval of convergence. So the radius is the distance from the center for which the power series will match the function exactly. Meaning if you have a radius of 1, you can stray up to 1 unit from the center, and whatever you plug into your power series with infinite terms, that will be exactly the function value. And the interval of convergence is the actual set of x values for which that's true, where the function matches the power series value with infinitely many terms. Describe the 3 basic forms of domain. So this just means like, what are your scenarios for the radius? So the radius could be 0, in which case your domain is only the center. The radius could be a number between 0 and infinity, which means the domain would be the center plus or minus the radius. You may or may not include the endpoints. Or the radius could be infinity, in which case the domain is all real numbers. Okay, let's take a look at this last problem. So for this last one, it says find the intervals of convergence for f and g. So for part A, I'm just going to start with f. I'm going to do ratio test. This becomes x to the 2n plus 2 plus 1 over 2n plus 2 plus 1 factorial times 2n plus 1 factorial over x to the 2n plus 1. So what will we have left? The limit as n approaches infinity of x squared over 2n plus 3 times 2n plus 2. And this is 0 because it's bottom heavy. So that means that the interval of convergence for f of x is all real numbers, -infinity to infinity. And if we do the same for g of x, the g of x, you get x to the 2n plus 2 over 2n plus 2 factorial times 2n factorial over x to the 2n. That leaves you with the limit as n approaches infinity of x squared over 2n plus 2 times 2n plus 1. That is also 0, so the interval of convergence for g of x is -infinity to infinity. Part B, show that f prime is equal to g of x. All right, so let's find f prime of x first. So this is the sum from 0 to infinity of -1 to the n. So this will be 2n plus 1 times x to the 2n, just x to the 2n, because you do plus 1 minus 1, over 2n plus 1 factorial. If we simplify that a bit, The negative 1 to the n is still there. The 2n plus 1 can cancel with 2n plus 1 factorial, and you're just left with 2n factorial, x to the 2n, and that is the series for g of x. All right, for part C, this one takes a little more looking at here. Show that g prime is negative f of x. So let's find g prime first. So g prime would be negative 1 to the n times 2n times x to the 2n minus 1 over 2n factorial. Now let's make an adjustment here. This is what I was talking about in an earlier problem. I didn't worry about it earlier because we weren't finding series, but here we're finding a series. This can't be n equals 0 because I would get x to the negative 1. So this series needs to start at n equals 1. Just a slight adjustment there. And then let's simplify things a bit because putting in 1 would make this, let's see. Yeah, because putting in 1 would make this x to the first. And that would be the first term of the derivative. So you would have n equals 1 to infinity, negative 1 to the n. The 2n is going to cancel down here, and you would have 2n minus 1 factorial over x to the 2n minus 1. Now, this isn't exactly what f of x would say, even if you put a negative in there. That's not really looking at that. So let's expand out some of these terms. So if we start at 1, we get negative, and then we would get x to the first over 1 factorial. And then put in 2, so you get positive x to the third over 3 factorial. Let's do one more term. Minus, putting in 3, x to the fifth over 5 factorial. Okay, so dot, dot, dot. And then let's look at, we're supposed to prove that it's negative f of x, so let's look at negative f of x. That would just be having f of x's series, which was, scroll this up a bit, which was this, just having an extra negative 1 multiplied in front of it to the n times x to the 2n plus 1 over 2n plus 1 factorial. So this is really just like negative 1 to the n plus 1, right? So let's generate those terms. This one does say start at 0. So if you start at 0, you get negative x to the first over 1 factorial. And then if you plug in 1, you get plus x to the third over 3 factorial. See how it's the same thing? Minus x to the fifth over 5 factorial. Dot, 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 dot. So they are the same thing. Okay, and then D, identify functions f and g. So f of x is the Maclaurin series for sine x. It's all of the odd powers of x, and g of x is the Maclaurin series for cosine x. All right, that finishes up this assignment. Please let me know if you had any questions for any of that.